Hey, this is TJ here with ShopBot Tools, and today I'm going to do a training on back to the basics. Here's we're looking at our 4 foot by 8 foot machine. Going to go over some terminology of the machine, different parts that are on that, and then we'll look into the control software that moves the machine around, and we'll look into the drawing software that we use to draw the parts that go on here. So just to go over some basic stuff. Well, the first thing here is you see this is a machine that has a 48-inch by 96-inch cutting surface. And it is called the X, the Y orientation on the axes, and then your up and down is your Z axes. All of our machines are made out of steel. They just come in different lengths and widths. You're going to have a spoil board on these. It's a sacrificial board. That's what your part will bolt down to or hold to. Our tools have a beam going across, also called a gantry, and mounted on that beam is a YZ car that moves back and forth along the Y, and then the spindle or router will move up and down in the Z. So there's just kind of the basic overview of the table. And now the electronics, you have a control box there which communicates with the motors. You type into your computer over here what to do. The machine will process it through the control box and move it around. You have a dust collector that sucks up the sawdust. And then also you have a variable frequency drive if you have a spindle. That's how you change the RPMs, the revolutions per minute that the spindle actually moves. So just a really quick look over some of the basic terminology you'll hear. Now here's that spoil board. And I want you to zoom in on this and really see. It's just a piece of MDF. And what it's designed to do is have you cut down into it a little bit versus not cutting all the way through your part. The spoil board's there for you to cut down into, say, 10 thousandths or so. That way you ensure that you've got cut all the way through. And then when the when the spoil board gets beat up, you can always resurface it flat, or different climates will make that warp and you'll have to resurface it flat again. So basically our machines move back and forth in an X and a Y and a Z location. So here you see it going back up and down the X, back and down the X again, and then the Z will also move up and down, and the first movement that I did was back and forth along the Y. So you can control that with the keypad and using the keyboard commands and move that around. The way our machines work is they all have a motor that moves back and forth along its axes, and what we have is a rack and a pinion. What I'm showing you here is this pinion that bolts on the shaft of that motor, and that moves back and forth along the rack. And that's how the machine moves back and forth on our bigger size machines. Our smaller ones use a ball screw and lineal rails. So here's a spindle that is on the machine. We can get different size spindles. You can get a Porter cable router. There's lots of different setups. And as you can see, there's lots of different types of bits. It's really important when you're changing the collets on these. These are a high precision collet they're called a spring collet, and you want to make sure that when they get taken off your machine that you check them every time, make sure that there's sawdust in them that gets knocked out, and they've got a lifespan about 400 to 500 hours, the actual spring collet. So that's probably one of the very few consumables that you'll have to get for CNC work. So I'm just inspecting these to make sure they're good. And it's always nice to have a second set around, because you've got multiple sizes here. Here's 3 different size shank holes for different size bits that I have. But it's also nice to have 2 of each one, just in case you damage a collet or it lost its lifespan. You've got another one sitting there so you can start cutting. But it's very important that you put those together and make sure you can't shake them apart, and then you can just easily twist them up onto the threads. You don't want to force that. So there's lots of different bits for doing lots of different cutting, and there's different collets for different size diameter. And watch how much I'm just going to take this and tighten it and then give it just a little bit more. You're not going strong on that. If you can actually over tighten that spring collet, and it will actually lose the spring in it. So this is the VFD. This is the variable frequency drive, and if you look, it has a digital display readout and it tells you what model it is. and this is what changes the different RPMs. On top of it, I have mounted the remote pendant, which has a start button, a reset button, and an emergency stop. And you can mount these in different locations on your machine. Now here's the control box. This is where all the electronics are to make the machine do what it does. That key right there is to engage your spindle or your router, so you can turn that off. And turn the power off when you open this up, and you'd even want to unplug it from the wall after you shut it off if you're going to be messing around inside there. But your main power comes in over here on the upper left, and then it filters down through the different electronics. You have a big board along the bottom that does a lot of the communication with the different motors and drivers. The black boxes right there are the 4 drivers, one for every motor. And there's also an accessory relay board that you can add over here on the left. Right here on the right, I'm showing you where the control card is. Right there on the left is the relay board. So that's if you have extra accessories like a air drill. The control card, the one that I made the little box to, that's going to say what version of your ShopBot is. That's really the brain behind the ShopBot, is that little control card. And then after that, I turn it on an alpha system like this. You have to hit the reset button, and that just brought the VFD to life and triggered the drivers. So here's a proximity switch and a hard stop. How do we get our machine to go to the same location every time with a routine that we have built in? Well, what we have here first is the hard stop, which is the gray rectangle, and that's bolted on there. So if the pinion was coming along and it ran up under this, it would stop it in place. This is an electronic proximity switch that I'm touching here, and there's the target that it goes over. When that hovers over that, it will actually throw off an error saying, hey, you've matched your machine limits and you cannot go any further. So you've got them on each side of the beam, and then you've got them on the length of your x-axis too. So you set those up initially on your machine, and then you're done. Here's the one along the x-axis. So there's the proximity switch, there's the target, and then there's the mechanical stop. So if it did somehow get past that proximity switch, that mechanical stop would keep that big gantry from falling off the machine. It would stop it right there. So you've got them on your X and your Y axes, and it's an optional Z axis you can get as well. So just using the software, there's a routine on there that I can hit an icon, and it's called your setting up your X and Y axes with the proximity switches. So it's just going to go up and touch the proximity switches twice in the X and twice in the Y, and then it goes to its location of 0, 0, and it will go to that same location every time unless you move your proximity switches. So it's now zeroed on the X and the Y axes. So that's how you zero onto your table as far as getting down into the corner. And here's showing it on the screen too. So you have an icon over here on the right, which if you hover over that icon, it will also tell you what the shortcut key is, that you could just click on C3 and type that in, and it would run that routine. So you can see it up in the upper right corner. It's going over, finding its proc switch, recording its location, and then stepping back. And that does that same thing every routine, so you always go to that 0. Now we can't do the Z-axis quite like that with this setup because we have all these different bits and different lengths. So we have something a little bit different that we use for that, and it's the same thing that we're making an electrical circuit, but we're using a Z0 plate. So the tip of the bit and the distance of the machine, I don't know yet. I just put that bit in there. But I can use this Z0 plate to calculate that. Careful, it does get a little bound up once in a while with the cords, but keep them straight. Nice flat surface, no sawdust underneath it. And I'm going to clip that onto the bit, or you could clip it onto the collet. And the first thing you want to do is check it. When you're touching this together, look over at your computer screen and make sure input 1 is turning green, coming on and off. And then just like before, this one has an icon that I can hit, which is click on the 1 icon, or I could type in C2, and it will go down twice and memorize that location. And now I know the distance between the tip of that bit and the table. And the beauty of this too is built into the software is the thickness of that plate. So I don't have to now go and measure that plate and say, okay, now I gotta increase my cut depth by this amount. It does it all for you. So that's how you zero the z-axis with this. And now our machine is in XYZ. It's all zeroed. I'd be ready to bolt my part down, and I would be able to cut. Now you do need a dust collector. There's a dust foot that goes on the bottom of the cutter, and then it tracks back along and then goes down to a dust collector. So what you want to try to avoid with this is having big loops or really sharp corners or kinks in that hose. The more free flowing you can get with your dust collection, the better it's going to suck up. So mine just follows up. I try not to have any real big kinks to it. That's as far as it kinks right there. And then this one's built on a sway arm just because there's a low garage door above it, so it needed a rotating arm. And then it goes down to a dust collector. And this is just a smaller dust collector. It only has a single bag. I just have to empty the bag more, but it still has enough power. That's just the single bag system from Grizzly Tools. So, alright. So there's just a quick overview of the machine. The next thing I want to do is show you the software that we use on the machine that is actually making that move around. So this is called SB3, ShopBot 3. So some of you might have seen this screen before but not have seen this command console. If that's the case, you have installed your software and it did it in easy mode, which is just this box, and it allows you to see some things, and it does have a few options here under the question mark as far as changing some values. But if you want to get into full mode, you could switch to full, and this is where I'm going to give you a quick demonstration today. So this is the command console. This tells you where the machine is at when it's cutting, and there's a lot of different things in here that I can explain, which is starting out with speeds. A lot of people will ask, what's the difference between a move and a jog? Well, what these numbers are is they're saying how fast that machine is going to move in an inch per second. So this one will move 2 inches per second in the X and the Y direction when we tell it to move someplace. And it will move the Z in 1 inch per second. Now down here is jog, where it moves a little, or I'm sorry, where it jogs and cuts and moves around the table at a faster speed. We're at 4 inches per second. So these you can change to your preferences, but I would recommend using how it comes in factory installed until you get used to it. But you can speed this up, say, if you're in more of a production type setting. So this is really just saying 4 inches per second. That will move in the X and the Y. And the Z, we just don't have it moving quite as fast, so it's down at 3 inches per second. So over here, the position menu, this tells you where the machine is. It's telling me where that bit is. So if I had just ran a C3, it would go over and find 0, 0 on the X and the Y. So this is telling me where the tip of my bit is out of my machine right now. It's at here in the X, the Y, and it's a ½ inch above the Z, where I zeroed it. These are different inputs and outputs. You'll see these turn on when you're doing your zeroing routines, your C3 routine. You can also hardwire things in here, like turning on your dust collector. Here's some icons down here that if you hover over them, they tell you what they are. This one is just a jog home. This one here is your C3. Zero your Z axis, or your X and Y, using the proximity switches. And then here is your Z. And then this yellow guy here, if you hover over it, you can also hit the K on the keyboard, and that brings up your keypad. Now keypads are pretty neat because when you first get your machine plugged in, the thing that is fun to do is bring up that keypad and use the arrow keys on your keyboard, or these clicking on these with your mouse, and move that machine around. Watch that gantry move around. Watch that YZ car move up and down, and move this to different locations on your table so you can see it. And then even get having a little bit more fun, you can say, hey, I want to actually move this to a certain distance, and I can say, hey, I want to move it to 1212, and say go to, and that machine will move over there. Up in the position menu, I'm watching it go. There might be times too, if you have a wireless mouse, you can hook up a remote, and then you could walk around to the other side of your machine, use your left and your right mouse keys to move it, Pressing down on that center scroll wheel switches axes to the Y, and now I'm moving the Y. Fixed is a nice if you want to try to line something up in a really close spot. By clicking on fixed, I can change this to whatever decimal I want, and then if you look up here in the position menu, every time I click, it just moves 10,000ths. So if you were trying to zero something in by eye and getting it really, really close, that's how you do that. And then there might also be times where you need to zero your z-axis, or zero any of your axes in that specific spot. Maybe you're not cutting in the bottom corner. Maybe you're cutting out in the middle of the table for a project. You got a piece of plywood already bolted down, and you want to use the second half of it. So you move it to the position you want and say, hey, I want to zero my x and my y right here, and watch what it'll do over here in the position menu. Boom. It changes that to 0, 0. So that's fine and good, but how do you get it back? So you would have to go back and either click on that icon or do your C3 routine, and it'll bring it back to the proximity switches. Then another thing that's really nice here is these memorized locations. You can come in here and make these different locations where you want them, and when you click on them, they'll go to that position. So this one here, it's moving to that memorized location, which is off the table in this sense because of where we had just zeroed it. So that brings me up with stopping that, and I can just go on here and right click these. Whoops, sorry. I can right click these and I can give it a label. Say, hey, this distance over here of where I'm at right now, I want this to be TJ's spot. That's where I like to go and crash my table at negative 1.9 inch. So I know every time I hit my spot, I'm going to crash it. So I honestly use it for a position of 9648 because as soon as I get done running a part file, that gantry always goes back to 0, 0. Well, I can now just hit the K button to bring up the keypad, and then whatever number you saved it at, you would hit 2, and boom, it would move to that position. So that's where the keypad's real nice. Now, some other things that you have in here along the top, here's where we can go in and say move or jog. Now these correspond directly down here to the speeds, but what I can do is come up here and go jog the X to 96 inches, type that in, and it will actually move over to that location. And if I didn't want to move it, if I didn't want it to run down the table as fast, I would have done a move instead. Another thing that gets overlooked a lot in here is your spindle warm-up routine. Underneath cuts up here, we have, if you go down to C5, it brings up a spindle warm-up routine. And this you want to run once a day before you use your spindle. It just helps take the bearings and let them get the grease thrown all over them before they're applied to a cutting load. So it's something you'd recommend doing. You'd want to hit or turn your spindle on before you hit OK. And then what it's going to do is it's telling you some lines of code here. It's telling me that I'm running at 9,000 RPM. It's going to pause for 180 seconds, and then it's going to turn router to 10,000, pause again, turn router to 12, and then run for another 180 seconds. And then finally it'll shut off spindle. So those are what's going on there in your lines of code, and we'll look into that here a little bit more in a minute. So to get out of something, since we don't want to sit here for the time and watch this, I can always hit spacebar, and spacebar will bring up the stop hit. So this could be something where maybe you needed to just stop it and go check on the file, or you needed to answer a phone call and then hit resume and go back. If you knew something wasn't right, you could just quit. You can insert different commands at this point. So I'm just going to quit out of there. Just going to quickly go through that. Another thing that's nice is, say you just ran a file that was 45 minutes long, and you're 40 minutes in, and maybe you have to shut down the machine because school's over for the day, and you got to come back tomorrow. It's not always ideal, but you don't want to come back and have to run the full 45 minutes again. But what you can do is go File, go to Line, Single Line, and then you can find your file, open it back up and say, hey, I was actually all the way down on line 900, and then run, and you can go and then run from here. So I'm not going to run that, but there's an option for you to go to line. And I guess the last thing too is, just because we're doing a quick overview on this, is you've got the help menu up here, and that tells you a lot of different things. It tells you some different references. It's a user's guide in here. There's a lot of keyboard shortcuts. It talks about things that are hidden here in the tools, like setting up ShopBot. It talks about there's a copy machine for using a digitizing probe to probe parts. There's a chip load calculator in here for figuring out how fast you should be cutting. So spend some time with the reference material. That will really help you dig into the software some more. So this is the control software. This is what moves that machine around. So the last software we need to look at is our drawing software. And we use VCarve Pro, which comes with your ShopBot, and it is made by a company called Vectric. And you get, when you install your thumb drive with your machine, you will get this drawing software. You'll get a 3D Partworks software, and then you'll also get the ShopBot command console that we just looked at. So this software is really nice because these guys are very good with their resources. They have lots of videos and tutorials. They have a 200-page help content that explains this all, and then there's lots of different shortcuts in here. And this software is real nice because you can just come into here. I can go create a new file. Depending on my table size or my part size, I would just come in here and say, okay, today I'm cutting on a 48-inch by 48-inch, and I got some 3/4-inch plywood. Well, I don't know about any of you guys, but I've never had 3/4-inch plywood be exactly 3/4 of an inch. So it's nice to have a good set of digital calipers and actually measure that and go, oh, whoa, this was actually 0.72. You can pick where you want to zero it. Sometimes people want to zero that Z plate on top of the material because maybe they're doing specific pocket depths, or they're doing a 3D carving that needs to line up at the top. Then there's other times where you want to zero to the spoil board, the machine bed, because you want to make sure you cut all the way through that material. Plywood isn't always consistent in its thicknesses, so sometimes it's more advantageous to zero to the machine bed. And then you can pick your zero locations, and again, we can go in and watch a lot of different tutorials on this, but basically you have all your different drawing icons over here. These are for creating vectors of certain sizes. You can create different shapes and sizes. You can manipulate these sizes and delete them. You can rotate them around. There's ways of rotating. All these different icons over here, they've all got shortcuts too, where you can just use one hand on the keypad and one hand on the mouse and do this, or you can come over here and use the icons. So what there's just some real neat features these guys have added into this, where if you had a certain part and you wanted it together like that, say, oh shoot, I want to cut multiple ones of these on this sheet, but I really don't want to draw them all. There's a feature for that called nesting, where I go in and say, hey, I wanted 8 of these, and then preview it and see what 8 of them look. Oh shoot, I can get 8 of them plus a lot more. Or I could change my tool that I'm going to be using. So a lot of neat things right here in this drawing software. And then when you get things drawn, you'll come over here to where you tool path them. So I'm going to bring up a file that shows you both the drawing side and the tool pathing side. And what it is here is the project. This is a Labyrinth. This is something that you'll see used in different schools where a student who has troubles calming down, what they'll be able to do is hold this in their hand and then take their finger and run this. Versus a maze that has different options, this just has one single track that goes from top to bottom. We've been using these lately in my wife's breathing classes for pregnancy, where during the birth, if they're having a lot of pain, they should be able to put their finger on this and it will help distract them from the pain and concentrate more on the breathing. So that's the project we're going to look at today. So I'm going to open up a folder here, and first things you should be looking at is this is the Labyrinth that I just showed you, but notice there's 2 files to it. You have the VCarve Pro file, and then you have a ShopBot file, and I'll come back to this and show you why in a second. So I open this up, and you can see here's the drawing already for this. So what we have on here is 4 of these. This is what fit on the sheet. So I moved these around so I could have 4 of them. So here's the different drawing icons that we use to draw these. Over here you'll have tool paths that will show you this in preview mode before you actually cut it. So the drawing of the thing is all on how well, just a matter of how long you play around in the software and start memorizing the different icons, and you'll get pretty efficient with that as you find yourself doing 2 or 3 different projects. And then the tool pathing end of it's really nice too, because if you came over here and you didn't have a tool path, you would say, okay, what do I want to do first? Well, the first thing I probably should do is cut out these grooves. I don't want to cut the profile out first. I want to cut out the little grooves first. And I tell it how deep I want it to go. I come into this thing here, which is really nice. This is called the tool database. So this shows all these different types of bits that you have on your machine, and you add these as you use them. Some of them come preset, and then you'll end up adding some as you need them. So even notice in here under this ShopBot starter kit for the desktop, underneath plastic, I've got a 1/4 inch upcut 13729. Underneath wood, I've got a 1/4 inch upcut 13729. And same thing under here for aluminum. So that same bit is used for 3 different materials. It just has different feeds and speeds. And we've got other tutorials up on how to calculate feeds and speeds. It's called chip load calculation. And pass depths. You know, aluminum being a lot harder material, we have a pass depth of 0.01. In the plastic with that same bit, we've got a pass depth of 0.25. So you can come in here and do that. For us right now, we need a 1/2 inch ball nose. So if that isn't in any of your starter kits, what you could do is create a folder and say, hey, I need to add a new bit. And you would get whatever bit that was. You'd get the information. This one was a ball nose 1/2 inch. If it has an Onsrud model number, you would type that in. I'm not sure if that's it off the top of my head, so I'm not going to put that in there. I'm just going to put TJ made as notes, so if somebody else was using this computer, they could go, ooh, I don't know if that guy has the right feeds and speeds or not. So then you just go in and type these in to what they needed to be. You hit apply and hit OK. So now I've got that ball nose. I've got my vectors highlighted. And how do I want to machine this? On the outside of the line, on the inside of the line, or on the line? Well, the way we design this labyrinth needs to be cut on the line for this part, for the track, and then it needs to be cut on the outside of the line for the base. So I'm just going to leave that on the line. Profile, track, on line. It's nice to have useful names, and hit calculate. And I am going to reset the preview and go preview visible toolpaths. Oops, I gotta click the toolpath, preview visible toolpaths, and then there that is. I can now come in and evaluate what that looks like. But let's add the through cut first. So I will select multiple ones of these by holding the shift key down, and I'm going to go back now and do a profile cut, but I want to make sure this one's on the outside of the line. I want to profile outside of these. However, what happened here is the cut depth. I forget how thick my material was, so I could just type in Z equals, and that brings up my material. But remember, I do have that spoil board out there, that sacrificial board on the top of the table, which I want to cut into just a little bit, so I make sure I cut all the way through my material. So I'm just going to say plus 0.01, which is 10 thousandths, like the thickness of a business card, and hit equals, and it changes that now to its depth. Well, I don't want to use a ball nose for a profile through cut. This is something you'd want to use an end mill for. So I'm going to look underneath my plastics, since I'm cutting this in plastic, for my upcut bit, and hit OK. And here is the number of passes it would go in depth. So 1/4 inch bit is a 1/4 inch pass approximately. That's good. You don't want to go too deep. You'll snap your bits off. If you wanted to be more conservative, you could add another pass. But this looks pretty good for this soft HDPE plastic we're about to use. I did confirm I'm on the outside. I can pick if I want it to go clockwise or counterclockwise. I can also add tabs. And what's a tab? What a tab is these little these little yellow T's, and you can place them or take them away wherever you want, and they're going to hold the part to the scrap material. And we'll call this one Profile All Parts. I'm also going to add something called a ramp, which you'll watch this thing ramp down in. Versus the machine plunging straight down into the material, a lot of bits, it's a lot nicer on them to ramp them in. And then this will be your message here that you will eventually see hundreds and hundreds of times. And the time that you don't actually end up reading it before you hit OK, you're going to do something that you don't like. Because that time will be the time that instead of saying 0.5 thickness, 0.51 cut depth. That's fine. We told it to do that up here. But the time you don't read this, you'll have accidentally put a 5.1, had your decimal in the wrong spot. And then that spoil board will be leaving you something to remember to read read what you're doing. So I can come in here and evaluate this. I can see that I've got a tab down here and the blue line. This red line is the machine at its move speed above. This turquoise line is the ramp going down in. And then when I preview this tab, I will preview it around. I see it makes its cuts. I see it left a tab in there. So that tab, if I look from the back side, is flush on the bottom, but not all the way on the top. Then I can just take a knife or something and nip that out of there. So doing this project, what I needed to do is I needed to go File, Save, and save that drawing file, which is just saving these lines and vectors. Now if you were to go out to the ShopBot and try to run that, it's not going to run a drawing file. It needs to be post-processed into code so it can read lines of code like I showed you during the Spindle C5 warm-up. And to do that, you'll actually want to select the toolpaths that you want to save, and over here on toolpath side, if you hover over this one, it says Save Toolpaths. And at this point here, you would save toolpaths to file. And notice it has a .sbp, and I want to show you that folder right here. So I've got the Labyrinth drawing file. That's the CRV. If you see there, right there, it says VCarve Pro file. And then I hover over this, and it says type ShopBot part file. So the ShopBot is only going to read this one. So this drawing file, that's what that looks like when you click on it. When I click on the ShopBot version, it's a whole different file. That post-processor, when you click Save, does all this work. It converts all of your drawings over to these lines of code. So to cut out these 4 labyrinths, we actually have 13,000 lines of code of it moving and jogging in different X, Y, and Z locations. So that's what's nice about the software there, that it'll convert that over just like that. And then to show you the video last of this thing cutting, and you'll be able to see. The last thing I would do is open ShopBot 3 again, make sure I'm zeroed in my X, my Y, and my Z, and then I would do a file part load, and then here's the machine now cutting that out. It's cutting out the track first, and there is an order of operations. We wouldn't want to cut the profile of the part out with just those little tabs holding it in place and then come and try to aug all this out of there. So you do want to make an order of your cut. And then it just follows it along. You have your dust collector on, sucking up the dust or the chips. You've chosen the right feeds and speeds. You've zeroed it in. It's all stuff that's playing around with some of these simpler projects that'll get you going, and you'll be able to get up and going in no time. And then here I changed the bit, re-zeroed it, and now I'm going to take that and you'll see it ramp in and then go at a certain depth, which is halfway down. It's going to come back down here and clean out where this ramp is along the bottom, ramp down a little bit further, and now make the final pass. And watch what it's going to do here. Come up, go over, go down. That's the tab. That's what's holding the scrap material to the finished part. So when I get done with this, I can take a utility knife or a chisel and pop those parts out of there. And another thing you want to do is verify that you can see through your part that you actually cut. The way this one's held down is just me throwing a piece of material up there, throwing some screws in it, and cutting it. There would be no way for me to unscrew this and put it back on there and line it exactly up. I'd need some sort of a jig or a fixture for zeroing it a little bit better than the way I did. So I'm going to use a vacuum or something, or a blow down in there and make sure that I can see MDF. I can see through there. So if you're cutting MDF, what would be a suggestion that you could do? Well, you could paint the MDF that is underneath. So, well, thanks for the basics. Please check out other videos that elaborate more into each one of those topics. And thanks for choosing ShopBot, and hope this video helped you guys get going with your ShopBot learning. Thanks.